Let's look at an atom of sodium. Where would sodium be on your periodic table? Okay.
It's in, not row. It's in.
What group is it in?
It's in group 1.
And what period is it in? 3. Therefore, sodium has an atomic number of 11. So if I'm going to draw an atom of sodium, all right, we're going to go with 11 protons, which means we're going to have how many electrons?
11.
Now, how many, what period is sodium in?
3.
How many electron shells will it need if it is in period 3?
We'll throw the answer. Oh, but.
If it is in period 3, it will need how many shells?
3.
It will need 3 shells. What group is it in?
1.
So how many electrons will be in the outermost shell?
1.
Yes. So let's draw an atom of sodium. So here's our atom of sodium. Now I want us to draw an atom of fluorine.
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 What's fluorine?
F.
It sounds like a name from the song. It's in period 2, group 1.
Period 2, group
No, group 7.
17. Group 17, right? So what is its atomic number? 9. So it's going to have 9 protons. Therefore, we'll have how many electrons? 9, exactly. So let's draw an atom of fluorine. So we have an atom of sodium here, and we have an atom of fluorine over here. Okay, now let's look at their valence electrons. Okay, valence, what is the maximum number of valence electrons you can have? Okay, 8, exactly. 8, and if we look at the periodic table, all right, if we look at our periodic table that has the Roman numerals on it, we'll see, so here, I'll even go and input it on the next one here. All right, add saved photo, and we will add this so that we know what we're talking about, and we can go back and forth. If I look at this guy right here, I can see my Roman numerals. What is the Roman numeral for fluorine? 7, right? My Roman numerals go to a maximum of 8. So elements in group 1 will have 1 valence electron. Elements in group 2 will have 2. Elements in group 13 will have 3. 14 will have 4. 15 will have 5. 16 will have 6. 17 will have 7. 18 will have 8. Okay? Now, knowing that, here's where it gets interesting. All right? When you have a non-metal and a metal that are bound, that are in the same solution, they will bond together by giving up or taking electrons from the valence shell. All right? Which one is my metal here? Sodium is my metal, right? My metal. Which one is my non-metal? Non-metal. There we go. Now, let's look at our valence shells here. How many valence electrons are in sodium? 1 outermost valence electron. How many should it have to be totally stable?
7 more.
It should have a total of 8, so it's missing 7, right? Is it going to be easier to give away its 1 to somebody else or to take 7? It's easier to give away the smaller number. Okay? Now, let's look at fluorine. What's its valence number of electrons? 7. So here's what ends up happening. When you have an element that has 1 valence electron and an element that has 7 valence electrons, like we do here, what ends up happening is this guy here will be like, oh, hey, I could totally stick to you, and you could actually take, okay, this little electron right here, and I could totally take this like this, and now look at it. What is the outermost shell? How many electrons are in the outermost shell now of sodium? 8, because there's no more electrons on its shell right now, right? It got rid of that one. It gave it away. So now we've got 1, 2, 3, 4, 5, 6, 7, 8. It's a happy camper. The only reason it remains happy is that this guy over here, who also now has 8, ends up going over and binding to this guy. Okay? Now, what we see here is something called an ionic bond. An ionic bond will always happen between a metal and a non-metal. Okay? If for some reason this little couple here was to break up, okay? If they were to break up, then the fluorine keeps the electron. If you break up, you don't get your stuff back. And it doesn't work that way, but we're going to get to that. Okay? Should have signed a prenup, but they didn't. So what ends up happening here, when they actually bond, okay, they're nice and happy, everybody's stable, this whole element is nice and neutral. Lord love you, same number of protons as it has electrons, yahoo. Okay? When they actually break up, though, how many electrons is this guy going to now have? Sodium. Sodium will only have 10 electrons, but it'll have 11 protons. Will it be neutral? No. What about fluorine? Fluorine has 9 positives. How many electrons would it have if they broke up? So would it be neutral? It would have an overall negative charge, right? It's a good thing they're not breaking up. Now, if we put them together like this, we say that this is called an ionic bond. And an ionic bond occurs when one element gives up electrons to another element. Okay, there's actual giving and taking. Okay? It happens between a metal and a non-metal. So when we go to name ionic compounds, all right, first thing we've got to look for is, now what would be the chemical formula for this? How many atoms of Na do we have? We've got 1, right? How many atoms of fluorine do we have? We also have 1. So if I want to write the chemical formula to this, which one goes first, the metal or the non-metal? The metal. So Na, and then big F or little f? Big F, because he's all by himself. So this is the chemical formula for this. What is its English, or what is its actual word name? What is the name of the compound? So when we talk about naming ionic compounds, a few little rules happen here. So the metal's name gets written out in full. It's still sodium. Sodium. But what ends up happening to the fluorine? It's not going to be sodium fluorine. No. What ends up happening here is the ending of the non-metal gets changed to IDE. Okay? So instead of being fluorine, we actually change this to IDE. So it becomes sodium fluoride. If this was calcium and chlorine, which one is the metal? Which one is the metal between Ca and Cl? Calcium is the metal. Chlorine is the nonmetal. What would this compound be called?
Calcium chloride.
Calcium chloride. Exactly. Okay? Does this make sense?